Greetings. We do some introduction to approximation and errors. So we know to say to approximate something means that is not the exact value. It may be the value that is close to the actual value, or maybe more than the actual value. And then errors, those are errors that we make by not having the actual value. So for instance, we have something that is weighing 9.5 kgs, then somebody says, maybe approximates to say it is 9.6 or 9.4, which is not really the actual weight. So then we are saying that those are errors. Now, we know that in anything that we do, in all the measurements, there is always an error. No matter what, an error is there. So what we are saying is that these errors are made through approximation. So after knowing what an approximation is, the other thing that we want to see is there is also accuracy. Accuracy means something being brought in the way it is, the actual measurement. Now, let us talk of these common errors that maybe will help us. In these common errors, what I mean is this. We'll have, let me just give an example. Maybe I can even draw a box. It can help us, I guess. Yeah. Okay, this will be better. It will help us. We may have 5 or maybe 2.2, 8.9, 5. Now, the other thing that I want to talk about here, it is absolute error. Now, this absolute error is in two ways. The first is that you may be given to say, maybe a teacher measured a tree with length 9.8 centimeters. Find the absolute error. So what it is here is that before we even find this, let us understand what this means. This is 5. It can be 6, can be 10, can be 12, or any number. So what it is here is that when you are told a question, or when you are given a question and you are asked to find the absolute error, and then the actual measurement is not given, provided that number is a whole number, then your absolute error is 0.5, which is half. Meaning the one representing the number, then 2, it is representing the division, which is half of that number. And then when it has one decimal place, when it has been put like 2.2, provided it is one decimal place here, what you do here, you begin with the first number, it becomes 0. As long as there's one decimal place, it means it will be 0.5. 2 decimal places, it moves 0.005, and so forth. But when the actual measurement is given, you subtract. So in this case, we are saying a teacher measured a tree with length 9.8 centimeters, meaning the absolute error from this measurement is 0.05. If the actual measurement was not given, then if the actual measurement was given, for instance, we say the actual measurement for the tree maybe was 10, or maybe was 9.5. If it was 9.5, we subtract the 2, but you make sure that you get the positive answer, and your answer becomes 0.3. Then this is considered to be your absolute error if and only if the actual measurement is given and the measurement which you made is given. I repeat, if and only if the actual measurement is given, that is when you deal with this. And that's how it goes. So for absolute error, anything dealing with absolute error, provided the number or the actual measurement is not given, follow this format here, you never go wrong. But if the actual measurement has been given, subtract the measured length from the actual measurement which was given, then that is considered to be your absolute error. Thank you.